Okay, here is our lesson on sets and subsets. So in this video I'm just really going to give you a few definitions. So our first definition is of a set or sets. Maybe I should just say set, no S. So a set is a group of objects. That's it. Or another word we'll say is a group of objects or elements. So it's just a collection of a bunch of things. That's it. So what do we mean when we say that? Well, I'll give you a few examples. So for example, we could talk about the set of all the fours in a deck of cards. In a deck of cards. So how many elements would that be? Well, there'd be 4 elements. So the way you could write that is call this the set A. And the notation we'll use is we'll put the elements of the set in sort of squiggly brackets. So there's 4 fours in a deck of cards. There's the 4 of hearts, the 4 of diamonds, the 4 of clubs, and the 4 of spades. And then to end the set, we'll just end it with a squiggly bracket. So this means that set A is the set of these 4 cards. And then sometimes we want to count the number of things in a set. So n of A is the number of elements in A. So in this case, n of A is equal to 4. So there's just one example. I could give you another example. Let's say B equals the set. Here's a more mathematical example of all positive integers. So B would be equal to, we could put all the elements in sort of set notation. So first positive integer would be 1, 2, 3. Now here's a problem. This is what we call an infinite set because there's sort of infinitely many members. Right? You could keep going on, 6, 7, 8, 9, 10, and really there's nowhere where you'd stop. So we could indicate that by just putting sort of dot, dot, dot to indicate this list keeps going on forever. And if you wanted to write n of b, well, you couldn't really because it's not a finite number. So there is no, it's an unknown number of elements. Well, it's an infinite number of elements. So there's another example. And then sometimes you'll see examples like this. Like let's say C equals the set of all the students at your school. Now here, if I wanted to list all the elements, I mean that's not really feasible, right? There's sort of 1,500 or so students at the school. So I'm just going to write, and this is kind of informal, you could write a squiggly bracket and then just kind of define the set. So all students at school. And then just kind of end it. So, every student that fits this property would go in the set. But then you could, n of C, the number of students at your school. I'm not sure exactly what it is, but let's say 1,522. Let's say there's that many students at school. So that means there's 1,522 students in this set. Okay, so that's what a set is. Another example. So I'm going to define what we call common elements. So a element, so this is one of those things that's in the set. Element is common to A and B if it is in both A and B. So let's say, for example, if A equals, let's say A is all students taking data management right now. So that would be everyone kind of in your class, right? Or in any other section taking data. And then B would be all students taking, let's say, another course. Let's say calculus and vectors. So anyone who's taking both anyone who's taking data and calculus would be a common element. So anyone taking both is a common element. So there's probably, I don't know, 10 or so kids, 10 or so students taking both data and calculus, so they would be common to both sets. Third definition is disjoint sets. So two sets are disjoint if they have no common elements. What's going on? What happened here? Sets are, it should go in there. Two sets, I don't know what these. Two sets are disjoint if they have no, can't write it M. They have no common elements. So just think of two elements. Computers having issues. So let's say A equals, we could use that same example. So all students taking data and then let's say B is all students taking, I don't know, like grade 9 math. So obviously there's no one taking data and grade 9 math. I mean, you're not allowed to take those both, right? You can't take data until after you've taken grade 9. So there's no one who's going to be in this set and this set. So that would be what we call disjoint sets. And a final definition is what we call a subset. So one set, let's give it a name. So A is a subset of B if everything in A, every element in A is also in B. So let's say A was all students in your class. And B is all students in your school. So basically what we're saying is everyone who's in A is also in B. And that should make sense, right? If you think of the 30 or so students in your class, do they also go to your school? The answer would be yes. So A is a subset of B. And then the notation, the way we write that, is A is, and it's kind of like a U on its side, is a subset, and we put a line under it, of B. So it just means everything in A is also in B. Right? So all students in your class are also students in your school. Notice it doesn't go the other way, right? B is not a subset of A because there are students at your school who are not also in your class, right? You can think of lots of kids that go to your school, so they're in set B, but they don't go to, they're not in your class, so they're not a subset, they're not a set of A. So those 4 definitions are going to be pretty crucial to our understanding of sets.